So whatever the operating system you have, like Windows, Mac, Ubuntu, based on that you can download the exe file. And you see the size, right hand side, it is less than 200 MB. So don't worry about if you have a low computational device, you don't have GPUs and i7 and big memory. Don't worry about that. It is so powerful but require less memory. So feel a simple system you can download and just install it. So once you install it, okay, you go to either icon on the desktop, or either you can search the R Studio. Like I have written R Studio. This is the icon you can see. Just open it. So you don't require much setup or configuration. So wait a while, it is going to configure and going to open the editor, like a you can consider very simple editor like a Jupyter or Spider, Anaconda for the Python. The parallel versions are there. So R Studio is one of the best editor for the R. So this is the screen. I'm not going to explain much about the R environment because it is not a talk about the R. What is the essential part that is the most important I will touch upon. So this is the area where you write the code like 2 plus 2 simple things. You can write the code. So here I'm going to write the every code that is you need to implement the linear regression over the medical data set. So first part and first important things comes in a mind. The where is the data set? You see the data set is here. Somewhere in the my local system the data set is there. I want to import my data into the R environment so that I can play with the data. So there is a two ways. You need to see the path. Where is the path? So this is the one path. You can copy that path, and by using that path, you can access that data set. So there is a two way. Either you can create or make that path as a root directory. The concept is root directory or working directory is better to say. Working directory means whatever the stuff you have saved in the working directory, you can directly access it without writing the complete path. So like if I made this path as a working directory, whatever the steps are here, I can directly access it. So that is a one way. Otherwise, every time you have to write the path. So how to set the working directory? So there is a command get wd and set wd. Get working directory. I don't know what is the current working directory. I don't know. So you have to write this command get wd. Sorry. Yeah. So look, see users like that is a currently by default working directly. My step is not over here. So what I do, I will copy my path. This is my path. I want to make that folder or that path as a working directory. So uh, what is the code to set the working directory? Set wd working directory. Okay, double quote. Copy the path, make it backslash. Only one change you have to make. Then your work is over. Yeah. Now you can check again, get WD. Yeah. This is the path is now working directory. Now I can access my data set into the R environment or you can say we can import it. So the next is how to import it. There are many ways to import the data. Why? Because there are various kind of data files. Some CSV, some Excel, some image data, video data, structured data, HTML data, JSON data, many ways the data set you may have. So R comes or rich in term of the compatible functions that you can use for import the data. So simple function that I'm going to demonstrate for importing the CSV file is the read.csv. You need to only give the name of the CSV file because it is already in the root directory. Otherwise, you have to write complete path over here. What is the string as a factor dot true? Don't go over there. I'm not discussing. It is a part of something else. So you see, this is the syntax where the read.csv you have to call the function or the path or the data set name you have to provide. and it will upload the data and it will save into the one variable. Variable name is up to you. Like variable name I'm going to give over here is the insurance. So it is up to you. A, B, C, D, X, Y, Z is the only variable name. So I'm going to copy that command, and I hope the command is very much clear to you. I just enter it. So within a second, the whole data set is successfully uploaded. Whether it is successfully uploaded or not, I don't know. So just that a variable. I hope that variable contain all the data. Let me write the name of that variable and press the enter. So if yeah, this shows that the data is now with the my R or session successfully uploaded. Now whatever the things I want to play with the data, I can do it. So if data is not clean, you need to transform the data. You need to delete the some unwanted features, unwanted variables. Many things you can apply. If data are missing, then you have to impute it. Many things you have to can locally you can do with the R environment. This data we are going to use for what? For training purpose. So that is things we have covered about how to import the data into the R environment. Very simple code is there. So I'm going to skip all those things here in between. Let me talk about little bit linear regression, because data is ready. We have gone through the data. We have seen what are the features are there. What is the internal features? What is the target variable? Everything we have seen. Now understand the algorithm that you are looking uh, to predict the medical expenses of a particular person. So the algorithm is the linear regression. I'm damn sure everybody who are attending this talk at least listen this name in the machine learning. Linear regression is a machine learning algorithm because it is a very fundamental and most studied or understood algorithm in the statistical or machine learning area. Even a beginner can know the linear regression. So linear regression is nothing but a simply equation of the line. If I say try to describe the thing, what is a linear regression? Linear regression is the equation of the line. So how to understand in data science point of view? So we have seen in our schooling equation of the line is like that. But this is the equation or way of representation is normally used mathematician. So when we come with the data science, normally people talk about like this. Like you have seen this one, B0 or you sometime you have seen theta0 plus theta1 x1 plus theta2 x2 dot like that. So these both are same, where C is the bias, sometime we can say. Okay, so this